All right, it's the last unit of Chemistry B. It also happens to be the last unit of your high school chemistry class. So, we're going to talk about nuclear chemistry. To get started with that, we got to talk about nuclear forces. But let's get you thinking, or let's get you telling me what you know or think of when you hear the term nuclear chemistry. Right, if you think of anything like maybe the nucleus, or like a nuclear reactor or nuclear bomb, then you're on the right track. Alright? And if you didn't think of any of that, no worries. And if you know more than that, awesome, but you're gonna know, even if you didn't know anything now, you're going to know lots by the end of this unit. So, nuclear chemistry is very different than what we've been doing so far. So far, we've been dealing with electron chemistry and, reactions that involve the valence electrons of our atoms. Nuclear chemistry involves your nucleus, all right, and the things that are inside the nucleus. So what particles are inside the nucleus? All right, we know there's electrons, protons, and neutrons. So what's in the nucleus? You said protons and neutrons. You were exactly right. So nuclear chemistry involves reactions or changes within the nucleus, which means that the nucleus is either going to gain or lose protons and or neutrons, right? Might lose just one or the other, or both. So nuclear chemistry gives off way more energy than our standard electron chemistry. All right, so this sort of chemistry, you're going to be able to tell you're dealing with nuclear chemistry because you're going to see reactions like this. They have all this extra information in there, all right? So just so you know what these mean, if you're looking at that symbol, all right, these numbers that are written are going to be your mass number and your atomic number. So mass number is always written superscript to the left or above on the left side, and then atomic number is subscript or lower on the left side. So let's review what those numbers tell us. What is the atomic number? What information does that give us? Yeah, think back way to chemistry A. All right, your atomic number tells you how many protons. All right. This is also a unique identifying number that each element can only have one atomic number, right? So if you change the number of protons, you actually change the element. You turn it into something else, all right? So and you can see that happening in this reaction. We had an atomic number of 92 in uranium, and afterwards, atomic number is 90, so now it's not uranium anymore, it's thorium. The mass number, as a quick review, in case you don't remember, that is your protons plus neutrons. All right? So you can use that mass number to know if anything is changing in terms of the neutrons. So, based on what we've known so far, I actually gotta wonder, why does the nucleus stay together? Because I know protons have a positive charge, and like charges repel each other. So those protons that are smushed together into that nucleus, it kind of feels like they don't want to be there. Now we do have those neutrons in there, and what charge does a neutron have? Hopefully you said 0 or no charge. All right, and that does kind of provide a little bit of a space buffer between our protons, but that's still not going to be enough to totally prevent them from wanting to get away from each other. So there's got to be something else going on. And there is. So, new terms. This word nucleon, all right, refers to any particle in the nucleus. So it's kind of a generic term that can mean proton or neutron. All right, and you know what? Protons and neutrons, they're not the smallest things that make up the atom. There's actually even tinier things called quarks that make up our protons and our neutrons. Right? There's two types of quarks, up quarks and down quarks. You can see the composition of protons is different than the composition of neutrons. And that's where their charges come from. All right, so like protons have 2 up quarks and 1 down quark. Those up quarks have positive 2/3 charge, and then that down quark has a negative 1/3 charge. You add that together, that's how you get the +1. All right. Your neutrons, on the other hand, have 2 down quarks and 1 up quark, and those negatives and positives cancel each other out to give us our overall 0 charge for a neutron. But in the protons, they're definitely positive, but they actually have some negativeness inside them. And then neutrons are definitely neutral, but they have some positive and negative charges inside them too. And that is what makes nuclear chemistry so interesting. All right, that attraction between the positive and negative quarks, that's what holds our protons together. That's what keeps your nucleus from exploding because the protons want to get away from each other. So, another component of the strong nuclear force is the residual strong force, and that's the fact that neighboring protons and neutrons their quarks can attract each other. So like the positive quarks of one proton can attract the negative quark of a neighboring one. All right, and it's this strong nuclear force that holds that nucleus together. And when I say strong, it is strong. All right, so when you are able to overcome that force and break apart the nucleus, it releases tons of energy. All right, so if you think about a nuclear bomb or a nuclear reactor, that energy is so big and, makes the bomb so destructive or makes nuclear reactor able to provide so much electricity because we're harnessing this power of the strong nuclear force.